The outline of this talk on the genealogy of Kuhn-type anti-realism is this. I start with the question what Kuhn-type anti-realism is. Then I start, for reasons that will become apparent later, with Copernicus. And then I talk about primary versus secondary qualities. Also, this transition is not obvious for most of you, probably. Then I will shortly talk about Kant, and then I come finally to Kuhn. At the end, I come to a conclusion in which we will see what the result of this genealogy is. So, let's first talk about Kuhn-type anti-realism. What is it? Well, first of all, it is a metaphysical position. It is not anything psychological. And I'm stressing that because many people who have read Kuhn and try to understand what Kuhn meant when he spoke about world change, that the world changes with a revolution, they thought that this is a psychological talk, talking about certain mental events, mental representations of scientists, but this is not what Kuhn meant. Whether one can understand that or not is a different question. But this is not what Kuhn meant. He means to articulate a metaphysical position. So this metaphysical position, which I call this Kuhn-type anti-realism, is opposed to straightforward forms of realism, for instance, to common sense realism, to scientific realism, or structural realism. What the relation is to perspectival realism is a more complicated question, which I'm not touching here at the moment. Then, what is realism? Now, the realisms that I'm talking about is the view that the real is purely object-sided, that the real is purely on the side of the object, as opposed to having genetically subject-sided contributions. And by genetically, I do not mean biology, but I mean the genesis of contributions. So, a realist says that the real does not have any contributions that come from the side of the subject. And indeed, for most realists, the idea that the real has genetically subject-sided contributions is for them a contradiction in terms, because for them, for most of them, the real just is what is completely mind-independent, and of course, having subject-sided contribution means some sort of mind dependency. So this is a big problem that realists don't even understand and think it's inconsistent to speak about something real also having subject-sided contribution, genetically subject-sided contributions. Now, if you find Kant's position, Kant's metaphysical position, then Kant says that the empirically real does indeed have genetically subject-sided contributions, which are fixed. It's the fixed, in Kant's terminology, forms of intuition and the forms of thinking which are fixed, and they contribute to the constitution of what empirical reality is. Again, for many realists, these are contradictions in terms, because the real just is, so to speak, by definition, what is opposed to the subject and therefore purely object-sided. Now, Kuhn-type anti-realism now means that the empirically real does have genetically subject-sided contributions, but in contrast to Kant, that are historically variable. That's very important. So it's a position that is somehow similar to Kant. There are some differences which I'm not discussing at the moment, but the most important difference is that the subject-sided contributions to the empirically real are in Kuhn-type anti-realism historically variable. This is where Peter Lipton has coined the wonderful expression that Kuhn is Kant on wheels. Now, the idea is that if we understand this Kuhn-type anti-realism, then we can also understand the concept of revolutionary world change that Kuhn uses in the famous chapter, or infamous chapter 10 of his book, The Structure of Scientific Revolutions. Because I'm going to give you the genealogy of that sort of metaphysical position that Kuhn was striking for. So I start with Copernicus. You'll see later why. Now, first, let me start with the old story. In the geocentric view, the observable motion of the sun and the other planets is real and objective. And I say the other planets because in this world picture, of course, the sun was a planet. So the observable motion of the sun and the other planets is real and objective, causally efficacious, and a property solely of the sun and the other planets that is purely object-sided. That was the geocentric view. You look out, you see the stars, you see the sun, and the motion is out there as a property of these objects, right? And this is now very important here. There was absolutely no difference between the objectivity and reality status of, for instance, the radiation of the sun and its observed motion. It was just, that was the sun doing. It was radiating and it was moving, and this was just reality. And of course, just out there with common sense realism, it's out there as a property of the sun. It's purely object-sided, no subject-sided contributions of any kind. Now, from our perspective, the implicit criterion for the reality of the sun's motion was what David Armstrong has called the Eleatic principle, I guess, namely, being causally efficacious is sufficient for being real. That's the basic idea. I think most of us really stick to that. It's sufficient, whether it's necessary is a different question, but it's something that's causally efficacious, that gotta be real. That can't be an illusion or a dream or anything. The content of a dream, I mean, the dream can be causally efficacious. So I think this was used there, and this seems to be quite a reasonable principle. And why? Well, the sun's motion produces the difference between day and night. And of course, the sun's radiation produces sunburns. And if you sit in the shadow and then the sun moves, the motion of the sun then produces the sunburn if you don't move away, right? So it's really real, I mean, by any reasonable criteria. All right. Now, as you all know, Copernicus claimed that the sun is at the center of the planetary system, and that this implies that the sun's and the planet's observed motions are so-called apparent motions, not true motions. Well, this is of course well known, but this has, why is that so? The apparent motions, so the motions that you observe, the apparent motions are generated by the Earth's rotation and motion, projected onto the sky, together with the true motions of the objects. So the sun has a very simple motion because the true motion in this perspective is zero. So we just see the projection of the Earth's rotation during the day and during the year of the Earth's motion. With the planets, it's more complicated, with these relative motions there. But I don't go into that detail here. And now to put that in the language that I introduced earlier, the observed motion of a celestial object has genetically object-sided contributions, namely the object's own true motion, and genetically subject-sided contributions, namely the projection of the Earth's rotation and motion onto the object against the sky. So what we see is the motion of the sun is this mixture, amalgam of object-sided contributions and genetically subject-sided contributions. And now this is very important, that the observable motion of a celestial body is a phenomenologically inextricable mixture of the projection of the Earth's rotation and motion and the object's own motion. And you see that mathematically it's simply vector addition, so there's absolutely no difference between the two in quality. You just add them up, and if you look at the phenomenon, namely of the motion of the celestial object, there is absolutely no way by analyzing the phenomenon and therefore tearing apart the genetically subject-sided stuff from the genetically object-sided stuff. This is very important. Observation alone cannot tell these heterogeneous contributions apart, not even in the case of the retrograde motion of planets. Which, of course, the planets then go backwards in comparison to their general direction, and you can observe that. but you can observe the phenomenon as long as you want. There is no indication whatsoever that anything in that retrograde motion is really a projection from the Earth, namely a subject-sided contribution. You do not find that in the phenomenon itself. The analysis of the phenomenon is not enough to get to these subject-sided contributions. And this is, of course, one of the reasons why the geocentric system was so epistemically stable, because just analyzing the phenomenon alone does not bring you to the identification of that projection of what the Earth's motion, rotation and motion puts into the phenomena. That's very important. And the Copernican system has, apart from its direct massive substantial consequences in planetology, of course, methodological consequences of utmost importance, which I think have been underrated. And this is why I'm telling you this whole story in this talk, namely, real, objective, causally efficacious phenomena that appear to be purely object-sided are not necessarily purely object-sided, but may contain genetically subject-sided contributions. And the example here is, of course, motion of the sun and of the planets. So they are objective, causally efficacious, therefore they are real. They appear to be purely object-sided. You don't have to do psychology in order to realize that the sun is moving. No, you just look at the sun and you see it as you see the radiation. So all these phenomena that appear to be purely object-sided, they are not necessarily purely object-sided, but may contain genetically subject-sided contributions. Whether that is the case, and what the genetically subject-sided contributions possibly are, cannot be discovered by investigating the phenomenal qualities of the phenomena, but only by putting them into a larger theoretical context. Namely, you put them in the Copernican system, and then you look whether that's a simpler explanation, in the end also more accurate, blah, blah, blah. And then you say, oh yes, this has many, many, many advantages in comparison to the Ptolemaic system. And in that larger context, then you may get a grip on the possibility that the sun is really in the middle, and that this apparently purely object-sided phenomenon really has genetically subject-sided contributions. All right. In other words, what appears to be real and objective, and thus purely object-sided, may in truth contain genetically subject-sided contributions. This is what we learned from Copernicus, right? From Copernicus. This is not a philosophical speculation, but this is scientifically confirmed by the success of the heliocentric system. So when you understand Copernicus, I mean, this is science, it's not philosophical speculation. And what we also learned there, that the identification of these genetically subject-sided contributions is scientifically, of course, of utmost importance, because the genetically subject-sided contributions have to be investigated separately from the genetically object-sided contributions. So you first have to find out, or you have to find out, possibly independent of your planetary observation, on the Earth. I mean, can we somehow account for that? Can we understand the rotation of the Earth, and so on and so forth? And you put that in the larger new planetary system, and then you try to understand what's going on. So it's very important. Again, this is not philosophy, this is real science. And if you take science seriously, you have to take that seriously. This is at the basis of modern physics, of modern astronomy, and that of modern science at all. This is real science. This is not philosophical, speculation or whatever. Okay? So I think that Copernicus' discovery has had dramatic consequences for Western thought until today, much more than I think many people realize. And part of my talk will try to show that. The first, it triggered another distinction that was fundamental for the emergence of modern science in the 17th century, namely by the same figure of thought, that figure of thought that Copernicus used, and that is the following: something apparently purely object-sided, real and objective and causally efficacious, does in truth contain genetically subject-sided contributions that are phenomenologically undiscoverable. That is what we learned from Copernicus, right? And it's not only the scientific story of Copernicus, but that continues into the 17th century in the following way, namely for the distinction between primary versus secondary qualities. And that distinction between primary and secondary qualities was constitutive for the nascent modern physics, and all the main authors have discussed it, Galileo, Boyle, and so on and so on. And primary qualities were thought of as inherent in the respective objects, and the examples were the typical were geometrical shape, size, or motion. And the secondary qualities were qualities of an object, but that resulted from the interaction of the object with our senses. So, for example, taste, odor, color, sound, and heat. And with color, I come back to the topic we heard yesterday already. So this is the standard story. There are many modifications if you look in details, but I need only the course story here. And the fundamental thing, why did we need this distinction between primary and secondary? Because the primary qualities were the subject matter of the emergent mathematical physics. And the other stuff you cannot deal with the science of the 17th century. And therefore you remove the secondary quality, you give them another status, and then you can start with really mathematical physics. This is the beginning of modern physics. You need this distinction, otherwise you can't do it. And in my terminology, again, primary qualities are purely object-sided, whereas secondary qualities also contain genetically subject-sided contributions. And as we know, yesterday, Paul already mentioned it, there's no one-one correspondence between the primary and the secondary qualities, but that's not important in my context here. Okay. Now, what I'm saying is, and this is, I think, important, there is a fundamental parallel between the distinctions of primary versus secondary qualities and true motions versus apparent motions. I had that in mind really for decades. I didn't find anyone, no historian or anything who could confirm that this is the same figure of thought. I only found it then in Bird, 1932, Metaphysical Foundations, page 84. He's the only one who seems to have bothered about that, cared about that, but I do. And the fundamental structure that I want to turn your attention to is that in both cases, the pertinent phenomena later dubbed then apparent motion or secondary qualities were seen prior to that as purely object-sided. Why? Because of their phenomenological quality, right? So if you look at the color of something, I mean, you don't, by looking at it, I mean, it's the color of something. It is not in your head, it's out there. Like the colors of dinosaurs, by the way, they're really out there. And only in 2010 appeared a paper that said we have no idea what the colors of dinosaurs are. All the pictures you see of the colors of dinosaurs are pure fantasy. It's all rubbish. And then people thought, well, we will never be able to discover the color of dinosaurs because all this is organic stuff and we'll never find it in the fossil and so on. But then they found a trick in 2010. Anyway, colors are taken very seriously by very serious science, right? By paleontology. They want to know what the colors of these dinosaurs is. I mean, many of these people have children, and the children play with green and brown dinosaurs. It's all fantasy. It's all not science. Okay, so the things where these apparent and secondary things were prior to that purely object-sided and is causally efficacious, right? Colors are, of course, causally efficacious, not only to us, but also for bees, for instance. They go for color, and a loud bang may make you deaf, right? That's really a causal efficacious thing, and thus simply real, right? It's out there, it's causally efficacious, it seems to be purely object-sided or is purely object-sided, so it's real. I mean, there's no doubt about that, and therefore, of course, you find, apart from Democritus and Euclid, you find, of course, in antiquity and the Middle Ages, colors are real, right? It's just no discussion. They're just out there as real as any other things. All right. However, after the scientific revolution, these secondary qualities were put into a new theoretical context and thereby changed their reality status. Then people started thinking about them differently. They're only apparent causal powers were relocated to the true motions or to the primary qualities, respectively. So when you get a sunburn, because the sun moved, if you are then, enlightened, then you say, no, it's not the sun that moved, but, the earth rotated, and therefore I got the sunburn. So the causal agent is the earth, not the sun itself. So you have a relocation, or if you get the death by a loud bang, then it's not the bang that you hear, but it's this violent motion of the molecules that destroy something in your ear. All right. And the fundamental lesson of these insights in both cases, right, both Copernicus and primary versus quality, has been both for science and philosophy, for many, but not for all of us, I must say, has been this. Do not infer from the phenomenological quality of something as purely object-sided. The phenomenon tells you, I am out there, nothing else. You are independent. It's independent of you. It's mind independent. So do not infer from this phenomenological quality that it is really purely object-sided, because it may contain genetically subject-sided contributions that are phenomenologically completely hidden. Right? You have absolutely no chance to discover the origin of some of these like secondary qualities, that the origin may be in you and not outside, because the redness of that red Ferrari is just in the Ferrari and nowhere else. Right? You cannot dream it to be, well, you can dream it to be blue, but when you go next morning to the garage and then drive to the Institute for Philosophy, as most philosophers do, right, you find it, it's still red, right? It's out there. It's as real as its weight or mass or anything. So, for instance, the consequence is then, if you take that seriously, arguments trying to work from the phenomenological qualities of something alone to its pure object-sidedness are simply fallacious. For instance, here is one hand. You know this argument. This is completely fallacious. It doesn't take seriously the lessons of the first centuries of science or any other argument based on common sense. Because in common sense, we simply are naive realists, right? And what Copernicus and early modern physics tells us, don't believe common sense in these respects. It's just false. And now, extremely important, this is now addressing the realists. This is not skepticism. Realists tend to answer, yeah, this is skepticism, but this is simply post-Copernican thinking, or in other words, it is not philosophical speculation, but solid science. So if you say, some realists, they say, oh, look, these are these speculations of philosophers, common sense is much more solid. No. This is just the fundament of modern science. If you deny that, you deny all of physics. And this is a high price to pay, I guess. All right. So now I continue a little. A good part of theoretical philosophy from the 17th through the 19th century can be seen as attempts to identify the genetically subject-sided contributions in empirical reality. You can decode much of this discussion over 300 years, 250 years in these terms. And also, and this would be another chapter, important parts of the physics of the 20th century make use of the post-Copernican insight. Special relativity, you know, simultaneity of events seems to be purely object-sided. Einstein analyzing said, no, it depends on your frame of reference. There's a subject-sided contribution, right? Some interpretations of quantum mechanics, exactly the same. They say, look, the phenomena are just not completely independent of us. There is some dependency, and we heard yesterday from the other pole how this could be seen. So all I'm saying here is this is not an argument. It just says this sort of thinking is alive, and I can give you many other examples from the 19th century for the genesis of modern humanities and social science and so on. This is a figure of thought. Don't just trust the phenomenon when it presents itself as purely object-sided. Okay, now very quickly to Kant. This is not to convince anyone of anything. Critical Kant models his position explicitly upon the Copernican revolution. Only few Kant scholars take that very seriously. Critique of Pure Reason B16, you can find it there. And what Kant says, regularities in empirical phenomena may have been partly imported from the subject side. That means the phenomenon have fixed genetically subject-sided elements. Okay, you don't have to believe that. I'm just telling you this is what Kant thought. And Kant maintains that all real empirical phenomena contain genetic, subject-sided contributions. And this can be expressed in a certain way that then makes the connection to what I said earlier. All physical qualities are like secondary qualities, including space-time and causality, and we don't have access to the corresponding primary qualities. That is, in a nutshell, this is Kant's position. It's, of course, you can misunderstand it, but what not? What can you not understand? So, in Kant's view, empirical physical reality, nothing psychological, physical reality, real things out there, consisting of causally interacting material of things, thus contain genetically subject-sided elements. And the logic is not more absurd than Copernicus or secondary qualities. It's just the same logic. That doesn't say it's justified, it just tells you what the logic is. And what Kant then said, there is no other reality accessible to us. This does not preclude that we think about things in themselves, but that's not cognitive access. And just not to be misunderstood, I think that most of what Kant says is untenable today. And the reason is that mostly due to the massive change of science and mathematics since then. So you can't take any take-home messages from Kant. The substantive stuff, I think, is all false, but still it was philosophically extremely sophisticated. Okay, all right. So not that you think that I'm a dogmatic Kantian because I have a German passport. No. Well, I do have a German passport, yeah. Okay, now to Kuhn. All right. Now, from 1979 onward, Kuhn described his position as also Kantian, but with categories of the mind which could change with time as the accommodation of language and experience proceeded. So this is Kant on wheels, how Peter Lipton put it. And as in Kant's case, one can understand Kuhn's position by means of the secondary qualities analogy, by colors. I think this is very, very useful, that one, because the colors bring you back that something isn't real in the absolute sense, you know, of being absolutely out there, purely object-sided. Therefore, Paul also used it, and I've been in contact with Paul about that for decades. So, as I said, colors are normally taken to be real properties of things. And as I said, they can be the subject of a serious science, namely paleontology. What are the colors of dinosaurs? Right? Now, assume the standard view. Some people deny that, but assume it for a moment. Colors as phenomenal qualities of things are secondary qualities. They are an amalgam of genetically object-sided and genetically subject-sided components, you know, the surface of these solid bodies and so on, reflection and blah, blah, blah. All right, assume that for a moment. Now imagine something, that's a thought experiment. Imagine that all observable and theoretical properties of physical things are like secondary qualities, and at least as robust as colors, so that they don't, you know, change much with the change of the environment, as colors are fairly robust. So let's assume electron charge or something is a secondary quality. And that the genetically subject-sided contribution to these properties, which we assume now, are historically variable. But at the same time, we have no access to the purely object-sided components of such properties, meaning the corresponding primary qualities. Well, what are we doing then? Well, then we would take such observable and theoretical properties as simply real. Like what else? We have no, you know, we have a speculation, there can be something behind that, but of course they are real. So if something behind the charge of particles, it doesn't help us. The charge is the real thing. It does the causal job, right? Like colors in Western antiquity, all of antiquity, Middle Ages, everything, okay. This is the position that Kuhn very, very, very vaguely had in mind already in 1962 and tried to develop it. Okay, not very successfully. All right. Now, this metaphysical position would make revolutionary world change logically possible, right? Given that, then of course, the world could change, the world of real objects, not psychological, the real object, that could change, even if you don't like it, everything's unjustified, but logically it would be intelligible. Now, the real question is, I mean, is revolutionary world change plausible? Now we found only it's consistent, it's not self-contradictory. And now, of course, the important question is, I mean, come on, I mean, isn't that a completely crazy story, right? Is that in any sense plausible? I mean, isn't Kuhn, I mean, isn't he a crazy historian, doesn't know his philosophy, all right? Now, let us look at a contemporary example, dark matter. And of course, I know that Michela is here a specialist about all the empirical data, so I won't tell anything new to Michela, but for others. Now, dark matter was first hypothetically introduced in order to explain, among other things, galaxy rotation curves and gravitational lensing. These were phenomena that were extremely interesting in cosmology and astrophysics. And the only way one could see was, you know, the normal baryonic matter, as it's called, so the visible matter, visible to us, or interacting with us, that matter in non-gravitational waves as well. You know, it wasn't just enough, and for galaxy rotation curve gravitational lensing, and then people said there must be something else out there. That was a hypothesis first. And that has changed in the last 3 decades. And here's from a Nature article from 2018, Lisa Randall, a very, very noted cosmologist. She says, today cosmologists believe that dark matter is out there because of its manifold gravitational influences. Here you see again the Eleatic principle. Why do we believe it's out there? Because of its influences. So if you have effects that we interpret then as causal effects of dark matter. So why is dark matter out there? Because we feel its causal effects, so there's got to be something out there. We can say, speak about its quantities. We know it exists, but we do not yet know what it is at a fundamental level. So she says, we know it's out there. Unfortunately, we don't know its nature, what's its particles or whatever, but we know it exists. Look, it's there. We know it exists. But we do not yet know what it is at a fundamental level. Fundamental level in physics meaning, of course, particles, blah, blah, fields, and so on, and we just don't know. But we feel, you know, the effects of that stuff are so strong, and they are not explainable in any other way. That's the idea. Therefore, it must be out there, right? It's an abductive of course, reasoning, but it's so strong that today cosmologists believe that it's out there, right? We know it. All right. Thus, a cosmologist would say about the universe something like that. We live in a universe that contains our Earth, the Moon, the Sun, our galaxy, and many other galaxies and dark matter. That would be today and 2 years ago a very solid statement, and I guess 98 or something % of the cosmologists would underwrite that. This is our universe. We live in a universe that contains Earth, blah, blah, and dark matter. Now, in a similar way, this is something that Ernst Mayr, the famous biologist, always complained that philosophy of science doesn't take seriously the following, which he found extremely interesting. Biologists no longer speak of evolution as a theory, but consider it a fact, as well established as the fact that the Earth is round and not flat, right? And this is the same. You find the same sort of thing, not made explicit. But what Lisa Randall said, we know it exists, it's out there, and therefore cosmologists would say something like that. Dark matter is out there, like the Moon and the Sun. So it's not a hypothesis, forget it. No, it's out there, as the evolutionists say. Well, the fact of evolution, not the mechanism perhaps, but the fact of descendancy, that's a fact, that's not a hypothesis, it's a real fact. And Ernst Mayr complained that philosophy of science didn't take that seriously. In parentheses, Thomas Kuhn happened to take it seriously. Anyway, so now we know dark matter is out there. Now noted astrophysicist Pavel Krupa claims that there is convincing evidence that dark matter does not exist, right? And this is not from the last century, but this is from April 9, 2021, right? Very recently, in one of the golden webinars in astrophysics, which is, I can recommend strongly, it's very interesting. So Pavel Krupa gave a talk there, and on one of his slides, he said, the standard dark matter-based cosmological model is the most falsified model which the very vast majority of scientists have ever believed in, okay? So Krupa says, dark matter does not exist. Almost nobody believes him, right? Almost nobody believes him for various reasons. I'm not going into it because I don't need that. All right, so this is what Krupa says. Now, we don't know what's happening the next 10 years. I mean, some people know forever what is happening about science. I do not belong to them. I'm very open, and I have no idea what's happening in 1,000 years, whether we still speak about electrons. Other people know that. They have other cognitive abilities than me. So imagine now that Krupa convinces the astrophysical cosmological community within the next 10 years, right? Imagine that. That is, Krupa it's 50,000 citations. So he's not an idiot, right? He knows what he's talking about. He's fantastic arguments. Whether they're convincing or not, I'm not an astrophysicist, can't judge it. Okay, imagine that. Then in 2031, a cosmologist would say about the universe the following. she would say, we live in a universe that contains our Earth, the Moon, the Sun, our galaxy, and many other galaxies, and no dark matter. That would be the statement in 2031, given this imaginative scenario. Now, why don't we compare these two statements, the 21 and the 31 authoritative statements about the universe by the scientific community, right? By these relevant scientific communities. In 21, they say, the astrophysicists say, we live in a universe that contains dark matter, right? And in 2031, they say, we live in a universe that contains no dark matter, right? That is the scenario. Now, it's very important that you see that these statements are about the universe and not about our epistemic states, right? That's the same when you talk about it's full moon out there. You're not talking about your epistemic state and saying, look, from the impression of sense data, I get the impression that today we have full moon. No, you're saying out there is full moon, period. And you don't doubt it. And when somebody says, how do you know? Are you really sure? You say, I don't know what to talk to you, because that's the sort of, that sort of doubt that this is just useless. And no, it doesn't make sense. So note that these are statements about the universe and not about epistemic states. Take that very seriously. Now, a strictly non-Whiggish historian who does not reinterpret nor rephrase earlier statements of scientists in the light of current knowledge is thus forced to say that for the relevant scientific community, the universe changed between 21 and 31. Here are the statements, just read them and the universe changed, right? If you take that seriously. If you take that seriously, and a strictly non-Whiggish historian, of course, does take that seriously. Now, the phenomenon Kuhn is referring to with this world change talk, which is of course complicated and we don't know yet whether that's a good way to talk, is undisputed. The phenomenon Kuhn is referring to is undisputed. Namely, some scientists sometimes have very strong ontological convictions. For instance, dark matter is out there, right? They state them as facts, leaving no conceptual space for tentativeness. Right? If you look at that, what the cosmologist said, she said, we know it's out there, right? It's there, like the moon. It's nothing cognitive. Oh, it's a hypothesis. We don't really know, but perhaps, yes. No, it's out there, period, right? Nevertheless, these convictions are not immune against historical change. This is just what you see if you look at the history of science, of course, that's full of that. Scientists have very strong ontological convictions. They state them as facts. Well, and then 500 years later or 50 years later, it's different, okay? Now, normal people, of course, would rephrase a normal look here at the scaffolds. Normal people, not the non-Whiggish historian, would of course rephrase in 23. Well, in 21, cosmologists firmly believed to live in a universe that contains dark matter. And then he or she may add, but they were wrong. That would normal people say. But this is, of course, clearly a Whiggish statement about the situation in 21. Why? Because it's informed by the situation of a statement in 21, because it's informed by the situation of 23. So when you say that, normal people, they would say that, but of course they can only say that because they know what happened in 31. And a non-Whiggish historian would never do that. Remember what Kuhn already said in structure. It's very important here. The historian of science may be tempted to exclaim that when paradigms change, the world itself changes with them. Look at the phrasing. First of all, he doesn't talk about every Tom, Dick, and Harry, nor about every Tom Nagel, Dick Boyd, or Harry Frankfurt. He says the historian of science, and then he's very careful. He may be tempted. Well, he's not really sure because that sounds awful, doesn't it? And not only, he doesn't say to state, no, to exclaim in desperation, right? The historian of science may be tempted to explain that when paradigms change, the world itself changes, because if you're really taking your job seriously as a non-Whiggish historian, you've got to take seriously what scientists say at the time, and then you are forced to speak about world change. All right. Now, in order to gain access to Kuhn's metaphysics, one has to distance oneself from the absolutely overwhelming realist intuitions of common sense and this is not so easy for many people, of course. This distancing only opens a space of intelligibility and has little, if any, justificatory force, right? I'm only saying you've got to distance yourself from these intuitions in order to start to understand what other people are saying. This is not a justification of their position. This is what some realists think. Oh, if I start thinking along this way, oops, I'm lost already. No, it just tells you, here's a possibility, and then we find arguments whether it's a good possibility or a bad one, right? So my impression is that none of the fundamental critics of Kuhn has entered this space, this space of intelligibility. They just do not understand and stand in front of a closed door. And believe me, I've been discussing with realists for the last 30 years, and I have a list here with whom I discussed that, and it led nowhere, almost. Well, some people get a little weaker with someone. So there are various routes to this arduous intellectual opening that you get rid of this intuitions, these realist intuitions, and that the most traveled routes are, of course, that you study Kant's critical philosophy, but really study Kant's critical philosophy, not some secondary sources translated from Greek into Hebrew and then into English or something. No, you've got to really study it and understand it. And of course, quantum mechanics, because in quantum mechanics, you're also forced to think, oh, damn it, what is really real out there? Oh, wait a minute, we could be involved somehow. Okay. All right. The route I chose here is a genealogical one that includes, of course, the other routes. I could explain that in more detail. However, the justification of Kuhn's metaphysics, given one understands its outline, is a completely different matter. I'm only trying to to open something for understanding, and arguing for it is a different matter. So I'm not saying it's true or anything. I didn't give an argument. That argument would be historically based on the change of scientific ontology. So it seems to me it is possible to develop the kind of metaphysics Kuhn was groping for, but we haven't gone very far so far. And that means that the real discussion about the viability of Kuhn's metaphysics has not yet seriously begun. And now I'm connecting to the conference. This discussion must include its relation to perspectival realisms. There are at least 4, Michaela. Am I not right? Yes, thank you.